We're going to do by hand sketching, although we will check with technology. But this is a by hand method. We're going to verify it with technology. But yeah, we're going to sketch a cosine function in this video. And this video is about sine and cosine functions with 4 parameters. Pretty much this same video goes for sine. I'm going to just try it with cos. But basically, if you've got the function in the form of y equals a sine or cos, it doesn't matter greatly. That just really affects the starting point or the phase in the horizontal direction. A sine bx plus c plus d. And those parameters all have different effects on either the position or the shape of the basic functions y equals sine x or y equals cosine x. So you need knowledge of the basic graphs of those two, otherwise this video will be too far in advance of where you're at. So you need to know about them. We're not doing tan on this video. That's for some other time. Okay, tan's different. So that's what our focus is, and we're going to talk about what each of the parameters do in the video as we sketch it. Now, in terms of how these parameters, so a to d are the parameters, and they give the graph its transformations. Two of them are about the shape, that's A and B. So there we'll look at things like dilations. C and D affect the position of the points. So it'll be to do with translations. So translation and dilation. Hopefully you can link that to some other functions if you looked at. Now, what's very helpful sometimes is to do this. So if we can stick with sine, it's the same with cosine. If we can essentially factorize it so that we have the coefficient in front of the x in the brackets is a 1, so factor of b out there. If I take a factor of b outside of here, I've got c over b, and I leave plus d outside. If you expand that back out, you have bx and then c on b times b, which is just c, so you get back to where you start. But that's actually handy because that then tells us the more information about what's going on with the graph. Okay, it's more useful, as we'll see in this example. Now, this video assumes, apart from knowing about sine and cos, that you know some of the basic terminology to do with these graphs, as it is like amplitude and things like that, period, and the symmetrical and periodic nature of these two. So it's not a basement entry level video. Assumes a little bit of knowledge. So from this, with A, the magnitude of A, so purely the size of the absolute value of A, is the amplitude. Sorry, I spelt that wrong. Amplitude. And from your previous learning, you might know that the amplitude is half of the difference between the max and the min points in the y direction. B is a compression factor, or it's a dilation in the horizontal direction, and B is 2 pi over the period, or sometimes it's handy to go period equals 2 pi over B. Okay, C over B is a translation. So C over B is units translated in the horizontal direction. So a positive value for C on B would be to the left. Okay, so positive C on B is a phase shift or a translation left, in other words, to the negative end of the horizontal axis. And if C on B is negative, it's to the right or the positive. Okay, it's also called the phase shift. So it's a translation called the phase shift. And the lucky last there is D, and D is the mean value of the function in the y direction. It's also linked to a vertical translation above or below the x-axis. So let's have a look at our given function there, and we're going to sketch that in a second. We just want to factorize it first so that we have it in this form here. So here we go, we've got h of x equals 3 cos, now this is where we factorize it, 2 outside of x plus pi on 6, because that's C on B, so pi on 3 on 2 is pi on 6 plus 1. We've got a restricted domain between 0 and 2 pi inclusive. Now in the first instance we're going to get the shape right, so we're looking at those two parameters, and then in the second instance we're going to look at the two translations, the two shifts, and get the graph shifted. So that's, generally speaking, that's a good strategy for sine and cos. So here we are, and we're looking at that function, and we've got some axes set up here. Okay, and we're going to plot it from 0 to 2 pi, so 2 pi has got to be up that way somewhere. Let's look at the period first of all. So the period is 2 pi over b, b is 2, so the period is 2 pi over 2, which is pi radians. So it's being compressed by a factor of 2. So that will give us a bit of an idea on how we set up our axes. Another thing that we'll do that is what I call points of interest, POI, points of interest. The points of interest basically are every quarter of a period. So can you see what I'm writing? Because I'm left-handed, so I'm writing over the top of some of this. So every quarter of a period, we have a point of interest. So that means, what are the points of interest? Your peaks, troughs, and the zeros, the intercepts. Or the mid, when it's not translated, the midpoints. So if you think about the basic shape of cos and sine, you basically have, if it's cos it's like this, so you have a peak, a trough, and the halfway points, and if it's not translated they'll also be the intercepts, won't they? So they get affected too. So when you compress it, that's being compressed by a factor of 2. So these happen every quarter of a period. So these happen every quarter pi. So in this graph, it's every pi over 4 in the x direction. We will have a point of interest. So it gives us an idea on how we should set up our axis system. The other thing that gives us an idea of how we should set up our axis system is that, the 3. So it's going to have a dilation by a factor of 3 vertically, and so instead of going from 1 to negative 1 like it would on regular sine or cos, it's going to go up to 3 and negative 3. So if we have a look at here, 2, 4, 6, so I could go 1, 2, 3, and -1, -2, and I could just fit in -3 down there. It's a little bit compromised. That line there is just a separating line which separates working and graph. So that means we've got every pi on 4. So if we look at that, pi, 1 pi on 4, 2 pi on 4, 1 pi on 4, 2 pi on 4, 3 pi on 4, 4 pi on 4, 5 pi on 4, 6 pi on 4, 7, 8, 8 pi on 4. So that's 2 pi there. 8 pi on 4. This one's pi on 4. 2 pi on 4 is pi on 2. 3 pi on 4, 4 pi on 4, which is pi. 5 pi on 4, 6 pi on 4, which is 3 pi on 2. And 7 pi on 4, 8 pi on 4. So we've got our axes set up reasonably there. Just going to turn that light down a bit so you can see it. How's that? And time to start sketching. You should sketch this in phases. So the first phase is basically just looking at the graph of y equals 3 cos 2x. Okay, so without worrying about the translations, just looking at the shape. So that's what we're going to do first, and then we're going to put in these translations next. Okay, so we've got our amplitude, it's 3. We've got our period, which is pi. We're ready to plot that. So being cosine, it's going to start up here. Remember, you should know about y equals cos x if you're watching this video. Okay, so make sure that's in shot there, sorry. So starting it there, it will finish its period at pi. It's got to do 1 full cycle, so it'll be finished back up there as well. So some guiding points help. And pi on 2, so a quarter, we've got basically a minimum down here, okay, at -3. So it's going to come down as such. Whoops, that should be, I had that over too far, that should be underneath pi on 2. So that's the point, sorry about that. And so here we go. And by the way, if it was cos, it would be going through pi on 2 in the x-axis as one of the points of interest, because this is compressed, it goes through half of that, so it'll actually cut through there like that, and then it'll come up back up. Because of the symmetry, it'll go up through there. Yeah. So basically we've got that sort of thing, and it repeats again over this side here. So you can see we're going to finish up there. Is that in shot? It's probably out of shot. Look. So there, and the halfway mark at 3 pi on 2, we're going to be hitting at -3. So trying to keep this in shot is a tricky one. Okay, so a little bit rough, and sorry about the focus jumping around like that. So that's your basic y equals 3 cos 2x. Okay, so that's phase 1. So there we have a graph, albeit a bit ugly, and we now want to translate it pi on 6 units that way, because of in the graph here we've got the plus pi on 6, as we said before. Because that's plus, it'll translate the graph, all the points on the graph, to the left by pi on 6. So let's do that now. So it's probably easiest just to translate the points of interest to the left if possible. I'm going to start with this minimum down here where my finger is, where I'm pointing at there. Okay, that's currently in line with pi on 2, so pi on 2 take pi on 6. So pi on 2 is 3 pi on 6. Take 1 pi on 6 is 2 pi on 6, or pi on 3. So we've got to take it to pi on 3. Okay, so that's probably around about there. We move all of the points likewise over. This one is a little bit tricky because mine are in pi on 8th increments, and if you think about it, pi on 8 is about 0.125 pi, which 3 pi on 8 would be about 0.375 pi, so 0.3 would be a little bit less than 3 pi on 8. So that's kind of what we've got to do there. So we do the same with all of these points here, and it translates it over somewhat. And likewise, or if what I said just a second ago did make sense, we're shifting it by pi on 6, which is about half a radian, and pi on 8 is 0.4. So we've got 0.5 versus 0.4, and so if that is 0.4 there, 0.5 is a little bit further. So yes, my scale could be a little bit better, so that's a lesson into itself, but we're just moving all of the points a little bit more than one of those grid circle widths across. So hopefully that makes sense. So that one's going to go there, that one's going to go from there to about there. So if we had better, so pi on 12 probably would have been a better one for this. So I'm not going to reshoot the video based on that. We can get around it. It is a by hand sketch, so we can get by. So it's moving all these correspondingly about there. And that one goes to about there. It's out of shot. And so we're ready. You can see that it has translated now to the left, and that will hit somewhere there. And then our last one is to look at the translation of +1. So +1 there, we're going to look at that one. That moves all of the points up by one unit. Now a little thing here, the endpoints, basically where does it hit? The easiest one to find is where it hits the y-axis. So when x equals 0, that happens, and if you substitute that into the function there, basically you'll get 3 over 2, and because that's the beginning and the end, you know about the shape, that will be 3 on 2 over there. So you got your end points. Now we also need to make sure they're moved upwards by 1 as well. So here's our last step now. The final graph will be in blue. So 3 over 2 becomes 5 over 2 there. So 0, 5 over 2. And I can hear an industrial vacuum cleaner just outside my door. Isn't that great? Can you hear it on the video? And I'm sorry, it made me say the wrong thing. The final shape will be in black pen, not blue, because I've already used blue. Okay, so that's the previous high point there. That has to get moved up by 1, so that will go up to 4, which hopefully that's in shot there. That will go up to there, and likewise all the other key points like this one down here will go up by 1, and so on. So we've got some key points, you can see them emerge. So I've got put them in oversized spots so you can see them, and basically here it is. 5 over 2 is what 3 over 2 became when we add 1 on, and all of these have been moved upwards. Okay, and you can see that there, all of those have been moved upwards 1, and lo and behold we have our graph. Okay, probably the big mistake I made was I should have used pi on 12 there for my x-axis, but apart from that we have a graph by hand.